Chapter 10.2, Find Arc Measures. All right, a central angle of a circle is an angle whose vertex is the center of the circle. In the diagram, angle ACB is a central angle of circle C. So it said circle C, that means C is the center of the circle, and this angle right here, ACB, this angle right here is a central angle. If the measure of angle ACB is less than 180, then the points on circle C that lie in the interior of angle ACB form a minor arc with endpoints A and B. The points on circle C that do not lie on minor arc AB form a major arc with endpoints A and B. A semicircle is an arc with endpoints that are the endpoints of a diameter. All right, so this angle here is less than 180, and it forms this arc right here. So that's minor arc AB. Notice the symbol on top of AB is a little curve, okay? And AB is based on the endpoints of the arc. This is point A right here. This is point B right here. Now for the major arc, that is greater than 180. So this arc going in the other direction is considered the major arc, okay? And notice they used the endpoint letters for the first and third letter, and they used one other point on the arc, that is point D, which is in the center of the three letters. Okay, so they still use the endpoints A and B, but they use one other point that is on the arc to indicate that it is a major arc. All right, so the major arc is greater than 180. Okay, and the minor arc is less than 180. Okay, and we'll get to the semicircle a little bit later. Okay, minor arcs are named by their endpoints. The minor arc associated with angle ACB is named AB, arc AB. Okay, we just did that. Major arcs and semicircles are named by their endpoints and a point on the arc. The major arc associated with angle ABC can be named arc ADB. Okay, we did that. The measure of a minor arc is the measure of its central angle. The expression measure of arc AB is read as the measure of arc AB. Okay, so this M right here stands for measure, just like for the angles. The measure of the entire circle is 360 degrees. The measure of a major arc is the difference between 360 and the measure of the related minor arc. The measure of a semicircle is 180 degrees. Okay, so right here, they said circle C, so C is the center, and ACB is a central angle. Okay, we can see that angle ACB is 50 degrees. So the measure of angle ACB equals 50 degrees. Okay, as a result, that arc, the measure of that arc, from A to B, that's a minor arc, that is also 50 degrees. Okay, so the measure of the arc matches the measure of the angle. Now, if you go in the other direction, measure of arc ADB, so that's going all the way around from A to point D to point B. Okay, notice we almost went all the way around the circle, but we did not include this part here in blue. So all the way around the circle would be 360, and then you just subtract this part here in blue, which was 50, and you get 310. All right, so the measure of this arc here in red is 310 degrees. So you just subtract the minor arc from the whole circle, which is 360. And that's how you get the measure of arc ADB. This is major, this is minor. Example 1, find the measure of each arc of circle P, where RT is a diameter. Okay, by the way, when they say circle P, we know that P is the center of the circle. All right, and they're giving us that RT is a diameter. All right, so let's start with arc RS. We're going to find the measure of RS. Let's take a look. All right, so we can see this angle right here. That angle is 110 degrees. Okay, so if we travel from R to S along the arc, that's going to match this angle right here. So this arc is just 110 degrees. So the measure of RS, okay, that's arc RS, is going to equal 110 degrees. Now let's look at arc RTS, okay? I'll do it in a different color. RTS. All right. So if we start at R and go to T along the arc, and then go to S, we end up here. So we went almost all the way around, but minus this part here in red. So the measure of arc RTS, so I'm going to write MRTS with the curve symbol over RTS. That's going to be 360 minus this piece right here, which is 110. And that equals 250 degrees. All right. Last one is going to be RST. All right. Let me erase what we have here. And I'm going to go from R to S to T. All right. Now, they said RT right here. They said RT is a diameter. Okay. It goes right through the center and it goes to the other side of the circle. That means it cuts the circle in half. Okay. And we know that half of 360 equals 180. Okay, so since this cuts the circle in half, this arc right here is going to be 180 degrees. And the one on the other side is also going to be 180 degrees. All right, so arc RST, or should I say the measure of arc RST is just 180 degrees. Okay, so I went from R to S to T. That's a semicircle. All right, that's just half a circle. So they didn't ask us to write this, but just for your information, that is a semicircle, half of a circle. All right, two arcs of the same circle are adjacent if they have a common endpoint. You can add the measures of two adjacent arcs. So this is arc addition. Okay, it is just like angle addition. The measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. Let's take a look. All right, so they're looking to find the measure of ABC, arc ABC. So if you start at A and head toward B and head toward C, that is the arc we are trying to find. And if you add this part here in red, which is just AB, and this part here in blue, which is just BC, you will get the measure of the whole thing. Okay, so you can add the arcs together. They just added that arc and that arc to get the whole thing. Example 2, a recent survey asked teenagers if they would rather meet a famous musician, athlete, actor, inventor, or other person. The results are shown in the circle graph. Find the indicated arc measures. All right, first is the measure of arc AC. Okay, here's point A. Here's point C. If we travel along the arc, we have 108 plus 29. Okay, we're just adding this arc here, which is 108, and this arc here, which is 29. So that's going to equal 108 plus 29, and that's going to be 137 in degrees. Next up is measure of arc ACD. All right, so let's see. Measure of arc ACD. All right, so if we travel from A to C to D, okay, we're going to have to add these three. So that's going to be 29 plus 108 plus 83. All right, 29 plus 108 plus 83. And I get 220 degrees. Okay, alternatively, you can make the whole thing 360 and just subtract these two from 360. All right, part C, measure of arc ADC. Let's take a look. So we're going to do measure of arc ADC. All right, so if we travel from A along the arc to D to C, all right, we have this right here. We're going to add 79 plus 61 plus 83. All right, 79 plus 61 plus 83. And I get 223 degrees. All right, part D, measure of EBD. All right, so EBD, we're going to travel from point E to point B to point D. All right, so we have this whole thing. Now, the long way is to add 79 plus 29 plus 108 plus 83. You can definitely do that. However, we said before the whole circle is 360, so we can just subtract 61 from 360. So I'm going to do 360 minus 61. And that's going to be 299 in degrees. All right, so that's a little easier than adding four numbers. Okay, guided practice. Identify the given arc as major, minor, or semicircle and find the measure of the arc. Okay, let's just focus on finding the measure of the arc for now. And all of these letters, I am going to write these by the diagram. All right, let's do three at a time. So try these three, TQ, QRT, and TQR. All right, let's look at TQ. If we travel from point T to point Q along this arc right here, that's pretty simple. The arc matches the central angle, and that's 120. And that's in degrees. All right, next up is QRT. So travel from Q to R to T right here. So we have this right here. All right, so we have most of the circle except for the angle 120 here. So if we just subtract the 120 from 360, all right, 360 minus 120 is just going to equal 240. All right, and then finally, TQR, if we travel from T to Q to R right here, we have this right here. Looks like a semicircle to me, but just to make sure, we have 120. 120 plus 60. All right, 120 plus 60. And of course, that is just 180. So yes, that is a semicircle. Okay, please try QS, TS, and RST. All right, so for QS, we can start right here and travel along the arc to point S. So we're looking at this and that right there. Now, there's more than one way to do it. We can certainly find this angle here by subtracting these three from 360. Or another way we can do it, we can say all the way around the circle is 360, so just subtract 80 and 120. Okay, I would rather find this piece right here in case I need it for the other two. So I want to find this angle right in here. So I'm going to do 360, because that's all the way around the circle, minus 80, minus 120, and minus 60. And that is going to equal, let's see, 360 minus, this is minus 200. 360 minus 200 is 160. Minus 60 is 100. Okay, so I am just going to fill in this angle here as 100. And now it's much easier. Okay, so for QS, all I have to do now is just add 100 plus 60. And that's 160. All right, so that's a good lesson. I would fill in the missing central angles so it's easier to add when you go around the circle. All right, so if you have a lot of arc measures to calculate, you might want to fill in the central angles. Right here we have TS. If we just go from T, if we just go from going from T to S, point T to point S, we just have this right here, and that's 80 degrees, nothing to calculate. Okay, and let's see, finally, we have RST. So if we go from R to S to T right here, that looks like a semicircle to me. Okay, we said this one was 100, so we're just adding 100 plus 80. Okay, 100 plus 80, and of course that equals 180 in degrees. All right, so that's it. You can either add or subtract arcs. All right, two circles are congruent circles if they have the same radius. Two arcs are congruent arcs if they have the same measure and they are arcs of the same circle or of congruent circles. So if circle C is congruent to circle D, we can write it like that. Circle C congruent to circle D. Example 3, tell whether the red arcs are congruent. Explain why or why not. Okay, so we're looking at the red arcs here. And this one goes from E to F, and we can see that's 80 degrees. And this one goes from D to C, and we can see that one is 80 degrees. So the answer here, is yes. Okay, these are congruent because they are the same measure and they are on the same circle. Okay, you can't compare from one circle to the other. Okay, another circle, it might have the same angle, but the circle is bigger. So the arc is going to be bigger. Okay, but this one is yes, because same measure and same circle. Those are congruent. Part B, are these two arcs congruent? Well, let's see. This arc in red goes from here to here. This arc in red goes from here to here. All right, we can see the 90-degree angle. So the arcs are both 90. However, this one is on the smaller circle, and this arc is on the bigger circle. Okay, so part B is no, because they are on different circles. Okay, they might have the same measure, okay, that's the angular measurement, but that doesn't mean they're the same length. That doesn't mean they're congruent. Okay, in fact, we can clearly see this arc is longer because it's on the bigger circle. They have the same angular measurement, but that arc is longer. All right, now for part C, remember, if the radiuses or radii are congruent, that means the circles are congruent. So they should have said this is the center. I guess we assume this is the center. And this here is a radius. It's marked with the tick mark. This is the center. This here is a radius. This is a tick mark. So we have congruent circles. Okay, I'll just put the symbol for congruent. Okay, congruent circles. And the measure of both arcs is 95 degrees. So congruent circles and same measure. So are these arcs congruent? Yes. All right, so please tell me whether the red arcs are congruent here and say why or why not. All right, so right here again we have the radius. It's marked with a tick mark. The radius here is marked with a tick mark. Congruent circles have the same radius. All right, so we do have congruent circles. And the arc right here in red is 145. And this arc right here in red is 145. So we have congruent circles and same measure. Okay, so the answer is yes, the arcs are congruent. All right, please try number 8. All right, let's see. This arc here in red, it's 120 degrees. And this arc here in red is 120 degrees. So we do have the same measure. But this circle, the radius equals 5. And this circle, the radius equals 4. So same measure. However, the circles are not congruent. Okay, congruent circles, they need to have the same radius. This one is 5 and this one is 4. So the answer here is no. The arcs are not congruent.